So after you've looked up the authors and the publication, you can start reading the paper. Read through the abstract. That usually gives you an idea of the main goal of the paper, and then you start with the intro, section 1. Unfortunately, with a math paper, section 1 is often the most difficult to read. And this paper is not too bad, but in general, if you're looking at a math paper and section 1 gets tough, it is okay to skim section 1. There's no results in section 1 that you need for later. Often the later parts of the paper will reference back to section 1, but section 1 is basically going through everything very quickly without giving you full background, and then later in the paper should be easier to read. So do feel free to skim. This one, you should be able to read page 294 and 295, and then feel free to skim page 296. There's actually some stuff on page 296 that you will need some knowledge that you probably don't have. There's some material from Math 402 and 403, which you may not have taken, you may not ever take, and some other more advanced things. The good thing to be doing in the intro is to be asking questions that the paper might answer later. And it's okay if you try to answer them yourself now, just take some time to do that. If you can't answer them, that's okay, just be on the lookout for whether or not they're answered later in the paper. For example, one question I had was about this A over A plus B formula that they introduced on page 294, and we did talk about this on the homework for week 7. It was introduced in the card shuffling lecture. So my question was, why is it clear from the inverse shuffle, which they introduced, that these are the right probabilities? They implied that this would be clear, but I wasn't quite sure. And I kept this question in mind throughout the paper. They mentioned it one more time, and I still wasn't sure about it, but this, for me, this was answered on page 300. So, that's an example of how the introduction can give you something that seems confusing, that it's not a waste of time for you to think about it now, but that it might be answered later in the paper. It might not. So if you get to the end of the paper and it's not, you might have to think about it some more, or it might just be a difficult question. A lot of these papers deal with open questions in math, and it's okay if not everything gets answered. The other thing to bring up in the intro is on page 295, they mention inverse permutations, and they mention it in this context. They said if the number of rising sequences of some permutation, they call this pi just means a permutation, is notation for a permutation, standard notation. So if the number of rising sequences is r, then the number of descents of pi inverse is r minus 1. Okay, so a few things to talk about here. We need to talk about descents, we need to talk about inverse permutations, and we're actually going to talk about two-line notation. This notation is introduced on page 301, but it's a thing that a lot of combinatorialists know. So the authors of the paper might assume that you kind of know this at this point in the paper as well. So the example they give on page 301 is this permutation. So if you start with the numbers in order, 1, 2, 3, 4, 5, then you permute them, change the order to get 2, 3, 4, 5, 1. And note that this permutation has 2 rising sequences. We were kind of writing this as 2, 3, 4, 5, 1. And then the rising sequences, remember, you go look from the left, look for the number 1, and then we're done. You can't look for the number 2 anymore. Okay, so then you go from the left, look for the number 2, take all the consecutive numbers after that. So actually we see them all, 2, 3, 4, 5. So this is not a great example of what rising sequences are, but if you forget, you can look back in the card shuffling lecture. 2 rising sequences here. Okay, so this is kind of a condensed form of one-line notation. Usually there's square brackets. Sometimes there's not, but that's one-line notation. And the reason this exists is that in two-line notation, it's always going to be the numbers from 1 to the largest number in order on the top row. So one-line notation says you don't have to write the top row. This is a pretty standard notation for what combinatorialists use. If you do ever take Math 402, the algebraists use a thing called cycle notation, which is different from one-line notation. They make it sound like cycle notation is the only notation. Combinatorialists do know what this is, but in our work we find that one-line notation is much easier for the most part. In abstract algebra, cycle notation actually turns out to be much easier. So, a few different notations. Okay, let's talk about the inverse. Great thing about two-line notation is it's easy to find the inverse. So what we're going to do with this two-line notation, we're going to first switch top and bottom row. We'll just write this exactly as is, but with the top and bottom row swapped. So instead of 1, 2, we have 2, 1. 3, 2, 4, 3, 5, 4, 1, 5. And now this violates the rule of two-line notation. The top row has to be 1, 2, 3, 4, 5. So we rearrange the columns. So that the top row will be 1, 2, 3, 4, 5. Okay, so I need the last column first, 1, 5, and then I can take them from left to right. 2, 3, 4, 5. Write these under 1, 2, 3, 4. Okay, so if I go back to our condensed one-line notation, the inverse of this permutation is 5, 1, 2, 3, 4. And inverse just means if I do this one and then I do this one, I haven't done anything. I get back to my original order. Okay, that's an inverse, and I said we also had to talk about what a descent was. A descent is just as you go from left to right, if the next number is smaller than the previous number, there's a descent. So here there's 1. That's the only descent, because I go smaller and then bigger, bigger, bigger. Okay, so 2 rising sequences, 1 descent. That does seem to satisfy what they said. Number of rising sequences is r, so here r is 2. Number of descents is r minus 1. 2 minus 1 is 1. So that does satisfy it. Not a super interesting example, since there's a very small number of rising sequences and descents, but in your homework you will come up with a more interesting example.